Hi everyone, what's up? Welcome back to my tutorial channel. Daniel's here and today I'm making my third video in the series of elementary statistics. And today lesson I would like to continue working on basics ideas of statistics. And on the first two videos I talked about sampling and types of data. Actually today I plan to combine the last two topics into one single video, but then after I finished design experiments I realized that my video was quite long, so I have decided to break it into two videos. So today I would like to talk about design experiment, then next video I'm gonna talk about bias of study. So in design experiments, the first thing I would like to go over is the difference between experiments and observational studies. So to understand how a statistical studies works, let's look at this example. Suppose you are interested in investigate if one type of seed produce a larger wheat crop than another. So here's how you conduct a study. To illustrate how scientists address questions like these, we describe how a study might be conducted to determine which of the three types of seed will result in the largest wheat yield. So we prepare three identical side plots of land and those with similar soil types, and then we plant each type seed on a different plot, choosing the plots as random. Then we water and fertilize the plots in the same way, and harvest the wheat and measure the amount grown on each plot. So if one type seed produce substantially more or less wheat than the others, then scientists will conclude that is it better or worse than the others. So here is some terminology that we need to know in order to understand the difference between experiment and observational study. First, the experimental units are the individuals that are studied. These can be people, animals, planes, or things. When the experimental units are people, they are sometimes called subjects. So for example, in the wheat study, the experimental units are the three plots of land, and the outcome or response is what is measured on its experimental unit. For example, in the study of wheat, the outcome is the amount of wheat produced, and the treatment are the procedures applied to its experimental unit. There are only two or more treatments. The purpose is to determine whether the choice of treatment affects the outcome. So, for example, in the study of wheat, the treatment are the three types seed. So those are three treatments. So now we talk about the difference between experiments and observational study. So in general, studies fall into two categories: randomized experiments and observational studies. A randomized experiment is a study in which the investigator assigns the treatments to the experimental units as random. For example, the wheat study described above is a randomized experiment, and an observational study is one in which the assignment to treatment groups is not made by the investigator. So the difference is just like the treatment for randomized experiments is assigned by investigator, but for observational study the treatment is decided by the individuals. So for example, in studies of determine how smoking affects health, people cannot be assigned to smoke but choose for themselves whether to smoke. So people take control whether they want to smoke or not to smoke. But in randomized experiment, you see that like the investigator will assign to the units the treatment. So it's just like who decides the treatment. That's the main difference between randomized experiment and observational study. So now we are going to talk about randomized experiments. So in a randomized experiment, if there are large differences in outcomes among the treatment groups, we can conclude that the differences are due to the treatment. For example, if you are interested in comparing two types of vitamin, so you are going to assign these two vitamins into two groups. So for example, that's a vitamin for skincare. So after a few months, for example, you are going to compare the two groups to see if there is a significant difference between them, like between the people who use the first type vitamin and the people who use the second type vitamin. So if there are large differences in outcomes among the treatment groups, we conclude that the differences are due to the treatment. So, for example, to assess the effectiveness of a new method for teaching arithmetic to elementary school children, a simple random sample of 31st graders was taught with the new method, and another simple random sample of 31st graders were taught with the currently used method. At the end of 8 weeks, the children was given a test to assess their knowledge. What are the treatments in this study? Explain why this is a randomized experiment. So here you see that we have a simple random sample of 31st graders, and those were taught with the new methods. And another group, so we have two groups. One group is taught with the new methods, and one group were taught with the currently used method. And after 8 weeks, we give them a test to compare. So here we assign which group will be given the new method and which group will be given the currently used method. So in this case, we are the investigator and we decide the treatment. So this is a randomized experiment. So the treatment are the two methods of teaching. This is a randomized experiment because children was assigned to the treatment groups at random. So we decide, like the investigator decide which treatment is given into each group. And in randomized experiments, we have two types of randomized experiment. The first one is randomized block experiments. So in randomized block experiments, the type of randomized experiment we have discussed is sometimes called a completely randomized experiment because there's no restriction in which subject may be assigned to which treatment. For example, imagine that two reading programs are to be tested in an elementary school that has children in grades 1 to grade 4. So compared to the last example was between two groups. One group were taught by new method and one group were taught by currently used method, and we compare. So those are not block design, but here we have 4 group of children: grade 1, grade 2, grade 3, and grade 4. So in this case, we have two solutions. The first solution, we are going to take a simple random sample of 40 students in grade 1 through grade 4. Like we don't care which grade. We should simply take 40 students randomly. And then we divide them into two groups. 20 of them will be assigned the first program, and 20 of them will be assigned the other program. And then we are going to compare them. So in this case, this is just simply a randomized experiment. But in this case, the disadvantage is the group of 40 students might have more students of grade 1, for example, and is bring to the bias of the study. So we think about another solution to get rid of it. So we take a simple random sample of 10 students in each grade group. So for example, we take 10 students in grade 1, we take 10 students in grade 2, 10 students in grade 3, and 10 students in grade 4. And for each 10 student group, we divide them into 2 smaller groups, like 5 will be assigned the first program, 5 will be assigned another program. So here we have the blocks. We have 4 blocks, and in each block we have 2 groups. So this is a randomized block experiment because we consider the 4 blocks into experiment. And in this case, we get rid of the change that we have more students in grade 1 or we have more students in grade 4. So not only studying the effect of the 2-type program, we also study the effect of the blocks. Like these 4 students maybe have different outcomes. So that's how randomized blocks experiments work. So I repeat, we have to consider the blocks in the experiments. So that is randomized blocks experiments. The next thing is double blind experiments. So double blind, that means 2-way blind. So an experiment is double blind if neither the investigators nor the subjects know who has been assigned to which treatment. For example, if you want to, if you are interested in comparing 2-type vitamin, so you have 2 groups of people, like you have 2 groups of people and you have 2 groups of vitamin, like vitamin A and vitamin B. But here's the difference, like even you are the investigator, you're not allowed to know which treatment is given to which group. For example, we put a vitamin A and B into the two bags without the label. So you are going to give them to the people groups. So even the subjects and the investigator, we don't know which treatment is given until we finish the treatment, and we look back to the record to figure out which person was given which treatment. So this is double blind experiment. So that means 2 sides, the investigator and also the subjects don't know which treatment is given. For example, the experimenters had decided to give rotogravir to I don't know how to say the words, to about 2/3 of the subjects and the placebo to the others. To determine which patients will be assigned to which group, a simple random sample consisting of 462 of the 699 patients were drawn. And the sample constituted the rotogravir group. The remaining 237 patients were assigned to the placebo group. So here, like we this is a double blind experiment because neither the patient nor the doctor treating them knew which patients was receiving the drug and was receiving a placebo. So that is the 2 different types in randomized experiments. We have randomized block experiments and double blind experiments. So the advantages of double blind experiments, like we can guarantee the randomness better, like because both sides don't know the treatment is given. So the randomness is better, so the study is better. So basically, randomized experiment, the randomized block experiments and double blind experiment basically were designed to gain the randomness, like to make sure the randomness is satisfied, like very strong randomness. Okay, so that is randomized experiments. Now we work on observational studies. So recall that an observational study is one in which the investigator do not assign the treatment. In most observational studies, the subjects choose their own treatment. So remember, the difference between observational studies and randomized experiment is just simply randomized experiments, the investigator choose the treatment. Observational studies, the subject, the individuals choose the treatment. For example, smoking, the investigator cannot choose whether that person smoke or not, but that person will choose for themselves whether they smoke or not smoke. So that is the difference between observational studies. So in observational studies, there's one concept that is very important to understand the observational studies, that is confounding. So to understand the confounding, let's look at this example. Smoking is more prevalent among men than among women, and it is known that men have a higher risk of heart attack than women. So in this case, it is difficult to determine whether the difference in heart attack rates is due to differences in smoking, the treatment, or the differences in the gender. So here we don't know whether smoking or gender is the main factor that affects the heart attack rates. And in this case, because we are interested in smoking, we're comparing between smoking treatment. So the smoking is the treatment, and the gender in this case is the confounder. Usually the confounder is gender. Usually it is used gender is usually used as confounder. So a confounder is a variable that is related to both the treatment and the outcome. When a confounder is present, it is difficult to determine whether the differences in the outcome are due to the treatment or to the confounder. So that is about confounding. Now we work on two types of observational study. So there are two main types of observational studies, the cohort studies and the case control studies. First, let's talk about cohort studies. In the cohort study, a group of subjects, we call the cohort, is studied to determine whether various factors of interest are associated with an outcome. And in the cohort studies, we have three types of cohort studies. They're prospective, cross-sectional, and retrospective. So in the prospective cohort study, the subjects are followed over time. So here we are going to see the difference in a couple more examples. So in the prospective, the subjects are followed over time. In a cross-sectional study, measurements are taken at one point in time. And in a retrospective cohort study, the subjects are assembled after the outcome has occurred. So for prospective, is followed over time. For example, you give treatment this year, and every year you're gonna collect the results. So that means time does contribute to the study. Like you have to consider repeated over times. For cross-sectional study, we choose only one time. For example, today I give treatment and I collect the result and I make conclusion. I don't wait until another time to make another study. So the cross-sectional study is just measurements are taken at only one single point in time. And for the retrospective, like the subjects assemble after the outcome has occurred. So for example, we wait until the outcomes occurred and we collect a symbol. So let's look at some examples to understand those better. First, the Framingham Heart Study began in 1948 with 5,209 men and women from the town of Framingham, Massachusetts. Every 2 years, these subjects are given physical exams and lifestyle interviews, which are studied to discover factors that increase the risk of heart disease. So you see the key word here is every 2 years. So like it's repeated over time. Like this year they give them a physical exam to compare. Then 2 years later they continue another exam. Another 2 years they continue another exam. So the result is conducted over time. So this is a prospective cohort because the outcome was recorded over time. The second example, Lang and colleagues studied the health effects of bisphenol A, a chemical found in linings of food and beverage containers. They measured the levels of bisphenol A in urine samples from 1455 adults. They found that people with higher levels of bisphenol A was more likely to have heart disease and diabetes. So in this case, you see that the studies was conducted only one single time, like they measure and then they found that. So they don't wait until next year or the next year to repeat the experiment to record another result. So in this situation, this is a cross-sectional cohort. And the last example, Adams and colleagues sampled 9,949 people who had undergone gastric bypass surgery between 5 and 15 years previously, along with 9,668 obese patients who had not had bypass surgery. They look back in time to see which patients were still alive. So that means like they wait until the result come out. They should collect the sample of people who are alive. So this is an example of retrospective cohorts, because we wait until we finish the study to see who is alive to collect the sample. So in observational studies, since we have three types of cohort study, so we are going to compare these three. So for prospective cohort, the subject follow over time. That's the properties. For cross-sectional cohort, the measurements are taken at one point in time. For retrospective cohort, subjects are sampled after the outcomes had occurred. And here are the advantages. For prospective cohort, they give very good quality of data because the data were collected over time. So we consider time as another factor that make the study better. And also the potential confounders may be collected because over time there might be some other factor that also affect the outcomes, but those are not the treatment. And this study is the most reliable comparing between these three. However, like everything has two sides. So for this best cohort study, we also have disadvantages. That is two disadvantages. That those are prospective cohort is expensive because we have to consider over time. So every year, every 2 months, for example, we have to conduct another study. So it's expensive, and we have to wait a long time to have the complete result. So it's expensive and take a long time to record. For cross-sectional cohort, measurements are taken at one single time. So the good thing is it's not going to take too long. Then no time sequence of event is needed. But the thing is like the bad thing is there's little information about the past exposures may contribute to the outcome because we consider at this time. So the past exposures will be missing. Like we ignore the effect of the past exposure into today exposure and also in the future exposure. So we have no time sequence of events. So those are the two disadvantages of cross-sectional cohort. But the good thing for cross-sectional cohort is not expensive and it's very quick because you consider at only one single time. You make the study, you collect the outcomes, and then you got the conclusion. So it's not expensive. It's quick, but the disadvantages are the information is not enough. Like it's not reliable. For retrospective cohort, the subject assembled after the outcome has occurred. So it's almost impossible to obtain the data on potential confounders. That is one of the disadvantages. And also, it cannot be used to study rare diseases. Because for rare diseases, we don't have enough sample to study it. Retrospective cohort is hard to conduct. However, it's less expensive and it's very quick. There's retrospective cohort. Okay, so observational studies. In observational studies, so we have finished cohort studies, and now we go to the last one in the observational studies, that is case control studies. So case control study is actually very simple. In case control, we are going to have some group, and one group is the control groups. So for example, in a case control study, 2 samples are drawn. One sample consists of people who have a certain disease of interest, and that group is called the cases. And the other group consists of people who do not have the disease. So the group of people who do not have the disease is called the control group. So we have the case group and the control group, and the investigator look back in time to determine whether a particular factor of interest differs between the two groups. So they are going to compare the two groups to see if a particular factor is different between these two groups. So that's a case control study. For example, Nelson and college girls conducted a case control study to determine whether exposure to pesticides is related to brain cancer in children. They sampled 201 children under the age of 10 who had been diagnosed with brain cancer and 285 children who did not have brain cancer. They interviewed the parents of the children to estimate the extent to which children has been exposed to pesticides. So here we have two groups, the group of people who are diagnosed to have brain cancer and the group of people who did not have brain cancer. So this is case control. So in the case control study, a certain disease is taken into account. Like we compare between one group has disease and one group doesn't have disease. So we have only two groups for case control study. So this is we have the case control study. Like we have only two groups. Okay, so now we look back to what we learned today. Design of experiments. We have two main types: randomized experiments and observational studies. So studies fall into two main types: randomized experiments and observational studies. In randomized experiments, we have two designs, two basic designs: the randomized plot experiments and double-blind experiments. Those two, the purposes of these tools are to like make the randomness stronger, so we have better result, we have better conclusion, make the study more reliable. And in observational studies, we have case control study and cohort studies. Case control studies, we comparing one factor between two groups. One group does have disease and one group doesn't have disease. For cohort studies, we have prospective studies in which sequence of time is taken into account. For cross-sectional studies, we consider only one single time, and we have retrospective study. The sample is we sample after we got the outcomes. So that is everything we need for today, and now we are going to do some practice. So practice 1, true or false. Here I have 6 statements, and we are going to decide whether each statement is true or false. So in a randomized experiment, the treatment groups do not differ in any systematic way, except that they receive different treatment. Is it right or wrong? in randomized experiment, basically we have different groups. Each group will be receive a treatment. Yes, that's right. In this case, that is true. A confounder makes it easier to draw a conclusion from the study. This is false because sometimes we don't need a confounder. So the confounder is just like to for some situation that we have, but like just in some situation we need a confounder, but in general we don't really need confounder. So this is false. Next, in an observational study, subjects are assigned to treatment groups at random. Subjects are assigned to treatment. So this is wrong, because in observational study the subjects will be free to choose the treatment, not be assigned the treatment. So this is false. Remember the difference between observational study and experiments, randomized experiments. In observational studies, the subjects, the individuals, will decide the treatment, not will be assigned the treatment. So this is completely false. Next, observational studies are generally more reliable than randomized experiments. This is completely wrong, because randomized experiments is always better than observational studies. Because for randomized experiments, the investigator will choose a treatment, and we have considered block design and also double blind design. So the randomness is strong, and the result is better. So observational study are not generally more reliable. So this is false. Next, in a case control study, the outcome has occurred before the subjects are assembled. Is it right or wrong? This is in case control study. This is false. This is false, because in case control study the outcomes will be collected. Yes, this is true, because like we wait until the outcome has occurred to decide the subjects that is assembled. So this is true. The last one is a cross-sectional study. Measurement are made at only one point in time. So cross-sectional, yeah, this is true, because right at the definition of cross-sectional study, we consider only one single point of time. So this is true. Now we go to practice number 2. To determine the effectiveness of a new pain reliever, a randomly chosen group of pain sufferers is assigned to take the new drug, and another randomly chosen group is assigned to take a placebo. So first question, is this a randomized experiment or an observational study? Remember the difference between a randomized experiment and an observational study is just who will decide the treatment. In this situation, you see that a randomly chosen group of pain sufferers is assigned to take the new drug. So they are assigned to take the new drug. They're not free to choose the drug, but they are assigned to take the drug. So this is experimental design, randomized experiment. Second question, the subjects taking the new drug experience substantially more pain relief than those taking the placebo. The research team concluded that the new drug is effective in relieving pain. Is this conclusion well justified? This is yes, because the assignment to treatment is made at random. And remember, in randomized experiments, like if there is a huge difference between the two treatment groups, we can conclude that there's no systematic difference between the groups other than the drug taken. So it's just the difference between the type drugs. So there is no difference, systematic difference between the groups other than the drug taken that can explain the difference in pain relief. So that is that's all for today. Thank you so much for watching, and so today I have finished the experimental design, and we have one more topic in the basic idea of statistics, that is bias of study. So because when we make study, we also have sometimes the study is not reliable. So we need to see how much is reliable, how much is not reliable. So we need bias of study. It's just the degree to decide how much the study is reliable. So next video I'm gonna talk about the bias of study and also make connection between chapter 1 and chapter 2, because chapter 2 we are going to start with the descriptive stat. So before I start with descriptive stat, I would like to make the whole picture, like to let you see the connection between design of experiments, sampling, observational study, with descriptive statistics and inferential statistics. So next video I'm going to talk about bias of study and capture a whole picture for the difference between descriptive statistics and inferential statistics. Okay, so see you guys in the next videos. Thank you so much, and have a great night. Bye bye.